Today we're talking about long and synthetic division. It should be a review from what we did last year, so hopefully it will look familiar. So let's see what you remember. We're going to be factoring using long division. So the first thing we want to do is we want to see if the factor that they give us is actually a factor of the polynomial. So just like we did in long division last year, we're going to write the polynomial underneath the division sign and put the 2x minus 5 on the outside. I want to figure out what do I have to multiply 2x by in order to get 6x cubed. Well, since I need a 3x squared, I'm going to put a 3x squared up on the top. And then I'm going to multiply 3x squared times both of the terms that are on the outside. So that's going to give me 6x cubed minus 15x squared. I'm going to draw a line, change the sign, which means I'm going to change the sign of the 6x cubed. I'm going to change the sign of the 15x squared. So that becomes a negative 6x cubed, and it becomes a positive 15x squared. Then I'm going to add down. When I add down, I get 32x squared, and then I'm going to bring down the negative 104. And then I need to figure out what do I need to multiply 2x by to get 32x squared. Well, 2x times 16x will give me 32x squared, so I'm going to put a positive 16x up there. Then I multiply both terms by 16x. So 2x times 16x is 32x squared, and negative 5 times 16 is negative 80x. I draw a line, change the sign, so that's going to give me a negative 32x squared. That's going to give me a positive 180x. Then I bring down the I add down, which would give me negative 24x, and I bring down the 60. And then again, I'm going to do the same process. What do I have to multiply 2x by to get negative 24? Well, negative 12, which is there. So then I'm going to multiply, and I get negative 24x plus 60. I draw a line, change the sign, so that becomes a positive 24x and a negative 60. When I add down this time, I get 0. Since I end up with my remainder being 0, that means it factors, and it is going to give me no remainder, which means it divides evenly, which tells me it is a factor. And there we go. So we do know that 2x minus 5 is a factor of 6x cubed plus 17x squared minus 104x plus 60. But we're still not done yet because the direction said we had to factor. So now I'm going to be left with a depressed polynomial. The depressed polynomial would be 3x squared plus 16x minus 12. So if we look at the next page, I already know that I can factor 6x cubed plus 17x squared minus 104x plus 60 into 2x minus 5 and then this depressed polynomial. So now I need to figure out, can I take this depressed polynomial and factor it? Well, as a matter of fact, I can. And if I factor 3x squared plus 16x minus 12, I'm left with 3x minus 2 times x plus 6. So therefore, if I were to take the original polynomial and factor it, I would be left with 2x minus 5 times 3x minus 2 plus x plus 6. And that would be how I factor using long division. So here's another problem where I'm going to be factoring using long division. So I have 6x cubed plus x squared minus 117x plus 140. So I'm going to put the 3x minus 4 on the outside, and I'm going to put the long polynomial underneath the bar, and I need to figure out what do I have to multiply 3x by to get 6x cubed. Well, that's a 2x squared. So I'm going to multiply 2x squared times 3x, which gives me 6x cubed, and 2x times negative 4, which gives me negative 8x squared. I draw a line, and I'm subtracting those, so I'm draw a line, and I'm going to change that to a negative 6x cubed and a positive 8x squared. So I'm going to add down, which gives me 9x squared. I bring down the negative 117x, and then I'm going to do the same process again. In order to get 9x squared, I'm going to multiply by 3x, so that gives me 9x squared minus 12x. I'm going to draw a line, change the sign, so now I'm going to do 9x minus 9x, which is 0, and I add down, which gives me negative 105x, and then I bring down the 140, and I do the same process again. What do I have to multiply 3x by to get negative 105x? Well, it's negative 35. And I do the multiplication. I draw a line. I change signs. So that's going to make that positive, and that's going to make that negative. And now I know that my remainder is 0, so therefore it is a factor. So then I'm going to take this depressed polynomial, and I have to factor it because I already know that 3x minus 4 is a factor. So if I factor 2x squared plus 3x minus 35, I will get 2x minus 7 times x plus 5. So that means I can factor the polynomial 6x cubed plus x squared minus 117x plus 140, and I end up with the polynomial that's there. So now I want to find out if x minus 3 is a factor of 2x to the 5th minus 4x to the 4th minus 3x to the 3rd minus 6x squared minus 5x minus 8. And I'm going to do that using synthetic division. Remember, when I use synthetic division, I'm going to take the part of the polynomial that's down here, and I'm going to solve it. So it's like x minus 3 equals 0. When I do that, if I were to solve it, x is going to equal 3. So 3 is the number that goes into the box. Then I'm going to take the coefficients of all of my terms. Remember, if there are any factors or any terms that don't have a decreasing polynomial, like there's the 5th and the 4th and the 3rd and the 2nd and the 1st and the 8th, the constant. If I had any of those that were 0, like if this was minus 0x squared, I would have to put a 0 down here in my list of numbers, but in this case that doesn't happen. So I'm going to take my 2. After I've written down all of the coefficients down here, I bring the 2 down, and then I multiply the 2 times the number in the box, which is 6. Then I add straight down, which is going to give me a 2, which I multiply by the number in the box, which is 6. I add down, which gives me 3, multiply, put the 9 here, add negative 6 plus 9, which is 3, multiply that by the number in the box, which gives me 9. And then I'm going to add down, which gives me 4. 4 times the number in the box is 12. And then I add down, which is 4. So I've followed the procedure for doing synthetic division. All of these numbers down here are the coefficients of my depressed polynomial. Remember that when I did my original problem, my degree was to the 5th. So that means when I do my answer will be to the 4th. Notice that this time when I did that, my number here, my remainder, was a 4. That tells me that the x minus 3 does not divide evenly. So if it were asking if it were a factor of that particular term, the answer would be no, because it's not a factor because it did not divide evenly. But this time it only said to divide. So we did that, so we're good to go. So now that I have my coefficients for my depressed polynomial, this 2 that's right here is going to be my leading coefficient for my answer, which will be down 1 degree from where I was. So since it was an x to the 5th, now I'm going to take it down to an x to the 4th. So that would tell me I'm going to have 2x to the 4th, and then this is a positive 2, so that will be plus 2x to the 3rd, plus 3x squared, plus 3x plus 4, and then this 4 that's going to be here is going to be over the number I divided by, which was x minus 3. So if I were to put that in a nicer format, it would look like this. When I divided this polynomial, I ended up with 2x to the 4th plus 2x cubed plus 3x squared plus 3x plus 4 plus 4 over x minus 3. Now this was a little bit of an easier problem because this time I did not have a coefficient in front of the x when I was dividing. When I have a coefficient in front of the x when I'm dividing, I have to do a little bit of a different process. So here in this particular problem, notice that this time I'm dividing by 4x plus 1. There's a coefficient in front of the x. So the extra step that I have to do is I have to divide by whatever number is in front of the x. And when I divide, I have to divide by all terms by that number. So in this case, the 4 is in front of the x. So I'm going to divide every single term by 4. So that means every single term in the original polynomial that I'm dividing has to be divided by 4. And the numbers in the the denominator have to be divided by 4. So when I do that, 8 divided by 4 is 2, 38 divided by 4 and reduced is 19 halves, 5 divided by 4 is 5 fourths, 3 is 3 fourths, and this 3 is 3 fourths, and I have x divided by 1 fourth. And that shouldn't be divided by 1 fourth, that should be plus 1 fourth. There we go. So now I have my polynomial that I'm dividing that I'm going to use for long division. Just like before, I'm going to take the x plus 1 fourth, set it equal to 0. So that's going to tell me what number I'm going to put in my box. When I do that, I'm going to get x equals negative 1 fourth. So the negative 1 fourth is the number that goes in the box. My coefficients that I had before for my polynomial after I divided go in my line for my coefficients up there. And then I follow the same procedure. So I'm going to bring the 2 down and then multiply this 2 times the number in the box. When I do that, I get -1/2, and then I add down and I get I get +9. Then I'm going to multiply that 9 times the -1/4, and that goes here, so that's -9/4. And I add down, which gives me -1. -1 times -1/4 gives me +1/4, and I add down, which is 1. And then 1 times -1/4 is -1/4, and I add down, and I get 1/2. Again, we're going to look at the answers to what we're talking about going down a degree, our depressed polynomial. Since our original equation was an x to the 4th, that means this 2 down there is going to be an x to the 3rd. So there's my original polynomial, and I would have 2 times x to the 3rd plus 9x squared minus x plus 1 minus 1/2 over x plus 1/4. Now, you might say, wait a minute, we're not allowed to have a complex fraction there, so we have a fraction within a fraction, and you would be right. We're not allowed to leave it like that. So what we would have to do is we would be able to leave this polynomial the way that it is. Nothing really changes with that. So I'm going to change my last fraction here so that I have a number so that my number is not in the denominator and I don't have a complex fraction. So if I look at this fraction, the fraction in the numerator and the fraction in the denominator, my common factor is 4. So I'm going to multiply by 4 on the top and 4 on the bottom. When I multiply by 4 on the top, I'm going to end up with a 2 in the numerator. When I multiply by 4 in the bottom, I'm going to end up with 4x plus 1. So if I were to take this polynomial and change it from my complex fraction, I would end up with this whole polynomial of 2x cubed plus 9x squared minus x plus 1 minus 2 over 4x plus 1 as my answer. And that is how we do synthetic division. It was a kind of a quick review because we've done it already. Hopefully you remember how to do it now, as well as long division, and we'll practice this some more in class the next time I see you.